Hey everybody, in this video we talk about how to find all possible rational zeros using the rational zeros theorem. So let's say we're told to use the rational zeros theorem to list all possible rational zeros of this function. So let's talk about the rational zeros theorem. It says that first, it does not guarantee the existence of rational zeros, okay? Rather, it indicates that if a rational zero exists for a polynomial, then it will be of the form p over q equals the factors of the constant term divided by the factors of the leading coefficient. The rational zero theorem is important because it limits our search to find rational zeros if they exist to a finite number of choices. Because if we're given a polynomial and we're told to find the rational zeros, then there's an infinite number, right? An infinite amount of choices. But what this rational zeros theorem, it says, hey, wait a second. If it's a zero, it's going to be of this form here. So for this problem, f of x equals negative 2 x to the fifth plus 3x squared minus 2x plus 10. So all of our zeros, if they exist, okay, are going to be some x value, and they're going to be of the form factors of the constant term divided by factors of leading coefficient. So what are those? Well, the factors of the constant term, or of this 10, are plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. Now, the factors of the leading coefficient, or of negative 2, are just plus or minus 1 and plus or minus 2. So now what we do is we take any combination of these to get our possible zeros, rational zeros. So we could take plus or minus 1 over plus or minus 1, or plus or minus 2 over plus or minus 1, or, now, no matter what combination we do of a negative on top or a negative on bottom or vice versa, it's just going to be plus or minus. We can just do plus or minus outside the whole thing. 5 over 1 plus or minus 10 over 1. Now we can do plus or minus 1 over 2 from the 1 and then the 2 on the bottom. Plus or minus 2 over 2. Plus or minus 5 over 2. Plus or minus 10 over 2. But we have to be careful because it says be sure no value appears in your list more than once. So the plus or minus 1 over 1 is the same thing as plus or minus 2 over 2. So we're going to take that one out. The plus or minus 5 over 1 is the same thing as plus or minus 10 over 2. So we're going to take that one out. We're going to do the most simplified ones. So what are our possible zeros? Well, we can simplify everything by saying plus or minus 1 over plus or minus 1 is equal to plus or minus 1. And then 2 over 1 is equal to plus or minus 2, etc. for 5 and 10. And then we'll have plus or minus 1/2 as a possible zero. and then plus or minus 5/2 as a possible 0. Now remember, these are possible zeros. These aren't actual zeros. Right? These are possible rational zeros for our polynomial.